Introduction. In the previous chapter, we have already seen that 1. If the rate of work is constant, then the time varies directly as the work. 2. But for a given amount of work, the time taken varies inversely as the number of workers. Thus, problems on time and work are an application of direct and inverse variation. Before taking up problems, let us revise some rules. A. Suppose A can finish a piece of work in n days. Then work done by A in 1 day is equal to 1 upon nth part of the work, unitary method. B. Suppose that work done by A in 1 day is equal to 1 upon nth part, then time taken by A to finish the whole work is equal to n days. Example 1. If 28 men can do a piece of work in 65 days, how many men will do it in 35 days? Solution. If x denotes the number of men and y denotes the number of days, then x vary inversely as y. So, xy is equal to k constant. When x is equal to 28 and y is equal to 65, implies 28 into 65 is equal to k, or k is equal to 1820. When y is equal to 35, then x into 35 is equal to 1820, or x is equal to 1820 upon 35 is equal to 52. Thus, 52 men can finish it in 35 days. Example 2. Avisha and Neha together can paint a wall in 8 days. Avisha alone can paint the wall in 12 days. How long will Neha take to paint the wall herself alone? Solution. Avisha plus Neha can paint a wall in 8 days. So, Avisha plus Neha's 1 day's work is equal to 1/8 part of the wall. Avisha alone can paint the wall in 12 days. Avisha's 1 day's work is equal to 1/12th part. Therefore, Neha's 1 day's work is equal to Avisha plus Neha's 1 day's work minus Avisha's 1 day's work. This is equal to 1 upon 8 minus 1 upon 12. This is equal to 3 minus 2 upon 24 is equal to 1 upon 24. Implies that Neha alone can do the same work in 24 days. Example 3. A can build a room in 50 days. A and B together can build a room in 25 days. They work together for 15 days and then B goes away. In how many days will A finish the remaining work? Solution. Time taken by A to finish the work is 50 days. A's 1 day's work is equal to 1 upon 50th of work. Together, A plus B can finish the work in 25 days. So, A plus B's 1 day's work is equal to 1 upon 25th part of work. A and B work together for 15 days. So, A plus B's 15 days work is equal to 15 into 1 upon 25 is equal to 3 upon 5. Remaining work is equal to 1 minus 3 upon 5 is equal to 2 upon 5. Now, 1 upon 50th of work is done by A in 1 day. Therefore, 2 upon 5 of work will be done by A in the brackets, 2 upon 5 into 50 days. Hence, the remaining work is done by A in 20 days. Example 4. A, B and C can do a piece of work in 8 days, 12 days and 15 days respectively. How long will they take to finish if they work together? Solution. A can do a piece of work in 8 days. A's 1 day's work is equal to 1/8 of the work. B can do a piece of work in 12 days. So B's 1 day's work is equal to 1/12 of work. C can do a piece of work in 15 days. So C's 1 day's work is equal to 1 upon 15th of work. Therefore, A plus B plus C's 1 day's work is equal to 1 upon 8 plus 1 upon 12 plus 1 upon 15 is equal to 15 plus 10 plus 8 upon 120. This is equal to 33 upon 120. A, B, C together can finish the work in 120 upon 33. This is equal to 40 upon 11. This is equal to 3 and 7 upon 11 days. Example 5. Pipe A can fill a tank in 3 hours. Pipe B can fill it in 4 hours. And outlet C can empty the full tank in 6 hours. If all 3 pipes are kept open simultaneously, in how many hours will the tank be half full? Solution. Pipe A can fill a tank in 3 hours. Therefore, in 1 hour, pipe A can fill 1/3 of the tank. Pipe B can fill it in 4 hours. Therefore, in 1 hour, B can fill 1/4 of the tank. Pipe A plus B can together fill is equal to 1 upon 3 plus 1 upon 4 is equal to 4 plus 3 upon 12. This is equal to 7 upon 12 of the tank. Now pipe C can empty the tank in 6 hours. Therefore, in 1 hour, pipe C can empty 1/6 of the tank. Therefore, net result of the pipe A, B and C in 1 hour fill is equal to 7 upon 12 minus 1 upon 6. This is equal to 7 minus 2 upon 12 is equal to 5 upon 12 of the tank. Therefore, pipe A, B and C together take 12 upon 5 is equal to 2 and 2 upon 5 hours to fill up the tank, and tank will be half full in 1 upon 2 into 12 upon 5 hours. This is equal to 6 upon 5. That is equal to 1 and 1/5 hours. Time and distance problems. Special cases. Example 1. A train 300-meter long is running at a speed of 60 kilometers per hour. How long will it take to cross a tree? Solution. When a train has to cross a stationary object whose length is negligible, example tree, pole, etc., it has to cover a distance equal to its own length. See the figure given. Therefore, in this case, distance covered is equal to 300 meters. This is equal to 300 upon 1000 kilometers. This is equal to 3 upon 10 kilometers. Speed of train is equal to 60 kilometers per hour. Time is equal to D upon S is equal to 3 upon 10 upon 60 is equal to 3 upon 10 into 60 hour is equal to 3 upon 10 into 60 minutes is equal to 3 upon 10 minutes. This is equal to 3 upon 10 into 60 seconds, and that is equal to 18 seconds. Example 2. The speed of a train 150 meters long is 50 kilometers per hour. How much time will it take to pass a platform 750 meters long? Solution. When a train has to cross a stationary object with some length of its own, example platform in this case or a stationary train, then the distance which moving train has to cover is equal to the sum of the lengths of the stationary object and the train itself. See the figure given below. Distance to be covered is equal to 750 meters plus 150 meters equals to 900 meters. Distance covered is equal to 900 meters is equal to 900 upon 1000 kilometer. Speed is equal to 50 kilometers per hour. Time is equal to D upon S is equal to 900 upon 50 into 1000 is equal to 9 upon 500 hours. This is equal to 9 upon 500 into 3600 seconds is equal to 36 into 9 upon 5 seconds, and that is equal to 64.8 seconds.